Okay, solving equations. Okay, we have cosine 2t equals negative cosine t. Well, let's bring those over both onto the first side, the same side together. So cosine of 2t plus cosine of t equals 0. And I would like to factor, but remember, if it was cosine squared t and a cosine t, then I could factor and pull out a common cosine t, which leaves me with cosine t plus 1, okay? But with this 2t, you really can't pull them because they're not common. That's like saying the square root of 4 and the square root of 2, and you're like, oh, let's factor out a square root of 2. Nah, not going to happen that way, okay? They're completely different. So what we can do, though, is what we want to do is that it's okay that the angles are separate, because that's the whole idea behind these formulas that we learned in this lesson, okay? Is what can I replace cosine 2t with that'll shrink it down to a single t, and that way they match up this way, okay? Remember, we have the formulas for cosine of 2t. They're either cosine squared t minus sine squared t, or it's going to be 2 cosine squared t minus 1, or 1 minus 2 sine squared t. Okay. Well, since my other term has just a cosine t, I'm actually going to go with this middle one again, so it's always all in term and just a cosine t. So we're going to write it as 2 cosine squared t minus 1, and then plus cosine t equals 0. Ordering this up so we can start with our quadratic term first, then cosine t, then minus 1. And now that shows me I have a quadratic, so all from here, all I have to do is factor. So I'll have 2 cosine t and cosine t. Factors of negative 1. Let's see, we have 1 and 1. Eventually it went out to positive, so I'll put a plus right there and a minus right there. So this first parenthesis is telling me that cosine t is going to equal a positive 1/2. And the next one tells me that cosine t is going to be negative 1. Okay, so let's wrap this up. My angles are just t's, so for one rotation, when are my x values going to be a half in radians? Well, the first time will be at pi over 3. That's in quadrant 1. The next time my x value is a half is in quadrant 4, and so that should be 5 pi over 3. For this other one, when are my x values equal to negative 1? That's only one time, and that's at pi within that first rotation. Okay? So my answers, if you wanted to box it up, are all that. And again, the book might list it in order. Increasing order would technically be pi over 3, then pi, and then 5 pi over 3. But like I said, you don't have to worry about doing that. All right, this next one. I have sine of 6t and then 2 sine of 3t. I want to get these angles to be identical, and the only way I can do that is to shrink the 6t. And with sine, at least, we only have one formula. So 2 sine of half of 6, which is 3, and then cosine 3t. So the formula tells me that all of that gets replaced with all of that, okay? And then 2 sine of 3t. So what we have right here are now two terms, and the two terms all match up, so it means we can go to the next step because they both have the same angle. Okay. What these two terms have in common, they both have 2 sine 3t, so let's pull that off. And that leaves behind a cosine 3t plus 1. Well, I have a product. Anytime I have a product, technically I've factored, it equals 0. So let's set each part equal to 0. You have 2 sine of 3t equals 0, and you have a cosine of 3t plus 1 equals 0. So this is, by the time I divide by 2, it's just saying sine of 3t equals 0, and this is saying cosine of 3t equals negative 1. So for 3 revolutions, when do I have a y value of 0? Again, that's always on the x-axis, so it's 0, 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So there's all 1 revolution, 2 revolutions, 3 revolutions. For the cosine 3t, when does cosine equal negative 1? Well, that's at pi, then 3 pi, and then 5 pi. So it only happens once per revolution. There's 1 revolution, 2 revolutions, and 3 revolutions. Well, you see how all 3 of these actually repeat in the top row? So I really don't have to, I can just kind of ignore this because they're all repeated up there. Because the next step we would do is divide by 3, and you're going to get the exact same answers either way. So let's come over here. So t technically equals 0 pi. It'd be pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is 2 pi. Box those answers up, and we can call them done. So if it repeats, if you happen to get the same one, it's very rare that you'll get some of the same numbers in both parts, but if they do repeat, just list it once. Okay, and of course, now that you've learned identities, we have to go into our process of actually proving them and showing that we can work with them inside of other identities. Okay, on our left, our angle is 2x. Everywhere on the right, our angles are single x's. So we want to replace the 2x on the left with something that can shrink it down to single x's. The formulas that we know to shrink with are both in terms of sine and cosine. So let's write tangent as sine of 2x over cosine of 2x. Okay. There's only one formula for sine of 2x. It's 2 sine of half of that, so x, cosine of half, which is x. The big question is, what are we going to do with the denominator? Because with the denominator, we have 3 options, so let me write them out. Cosine of 2x could either be cosine squared x minus sine squared x. It could be 2 cosine squared x minus 1, or it could be 1 minus 2 sine squared x. So which one do we go with? Well, my reaction is to maybe try the middle one again, just because over here on the right side, the denominator only has a single number on the bottom right, kind of like a single number right here. So I don't know, let's try it. Let's see, 2 cosine squared x minus 1. And if I'm wrong, guess what? This is the exact same step I'm going to go back to erase to and say, that didn't work out, let's try it again. Okay. Right, okay, what we need to do now. You know what I'm thinking? I'm already looking ahead. Ooh, I really am tempted to try this third one. Mainly because eventually I want to leave a 2 right there in the front, and I want to leave a 2 right there. So if I use this third one, if I can get rid of the sine squared, it's going to leave a 2 right there. Okay, I've already convinced myself. I think I'm going to switch it around. But you know, a lot of this time is just trial and error. I mean, as you can tell, it doesn't hurt. The more you practice, the more you know your formulas. Okay. Okay. We have one fraction going to one fraction. We have one term in the top. We have one big term in the top right here, 2 in the bottom, and again 2 in the bottom. So what I'm going to do is let's figure out what we need to multiply by to get these all to match up. So I'm going to go with the easiest one. What would you multiply 1 by to get this first term over here? Well, obviously it looks like cosecant squared x. So let's multiply the top and the bottom by cosecant squared x. Cross our fingers and let's hope we get it. So on the top it will be 2 sine x cosine x times cosecant squared x. In the bottom it's going to be cosecant squared x minus 2 sine squared x times cosecant squared x. Okay, looking good so far. And the top, okay, remember cosecant is 1 over sine, so that top is really saying 2 times sine x times cosine x times 1 over sine squared x. That's really what that top is saying. And down here in the bottom, I don't need to rewrite cosecant squared x, but that's exactly what I want. But here it says 2 times sine squared x times 1 over sine squared x. Okay, so that sine squared x can cancel with that sine squared x. This 1 sine x here can cancel with one of those right there. So what's left in the top is your 2. What happens if you multiply a cosine times a 1 over sine? Well, it makes cosine over sine, which is cotangent, and they both have that same angle of x. Down here in the bottom, you have cosecant squared x, and then 2 times 1 is just a minus 2. Check that off, and we're good to go. Okay, 5b. Well, looking at the top, we have sine squared x, sine x, cosine x, but a 2x. Everything on the right is x and x, so it looks like we only have one term we need to at least shrink for right now. So we'll leave the top the way it is. And then in the bottom, I only have one formula for sine 2x. It's 2 sine x, cosine x, and then minus cosine x. All right, anytime I want to reduce a fraction, I've got to have it all in terms of its factors. So let's factor the top and let's factor the bottom. The top would be 2 sine x and sine x with 1 and 1. It looks like the outside would be a positive, so the inside would be negative, so we get it all to work up. Down here in the bottom, the only thing that they have in common, since something's squared, I can't just set up two parentheses, but I can pull out a common term, which is cosine x, and that'll leave me with 2 sine x minus 1. Okay, so the 2 sine x minus 1s are going to cancel, and I have a sine x plus 1 over cosine x. Okay, so right now I have a fraction. My answer, though, has two terms. So in order to break this up so I can have two terms, I'm just going to split it. So sine x over cosine x plus 1 over cosine x. Sine over cosine is tangent x. 1 over cosine is secant x. And we have our answer.